Hello, folks of geometry. Welcome to Unit 5. This is the final unit for Geometry A. So congratulations on making it this far. And this unit not quite as long as some of the other units, but it's not without its challenges. So please do what you can to kind of make sure that you are wrapping your minds around kind of the concepts and seeing kind of what the big ideas are. So we're going to start with ratios and proportions, kind of what those are and how those work. And then we'll kind of go from there, and you'll kind of see how it applies to shapes and polygons and things of different sizes, and kind of see how they're related. Okay, so what is a ratio? A ratio is basically anything that compares two numbers. That's a ratio. It's something that compares two numbers. Probably one of the most familiar ratios that you're used to is simply a fraction. 1 to 3 is a way to represent a ratio. Okay, that might be the one you're most familiar with. So generally it's A over B. Some of the other ways it's written would be A to B. With a colon in between there. So these are generally the ways that we write a ratio. Okay, so a ratio just compares two numbers. That's all we're doing. That's all a ratio does. You're just going to compare two numbers. So as we look, a baseball player's batting average is the ratio of the number of base hits to the number of at-bats without including walks. Okay, so no walks. So if you're not familiar with baseball, so you're trying to get on base by hitting the ball in play and beating the ball to the base. And if you get 4 pitches that are not, in the strike zone, then you can go to first without hitting. But we're trying to look for hits and number of at bats. Okay, so Joe Mauer, back in 2006. He had 521 official at-bats, so that means, at-bats minus walks, and 181 hits. Find his batting average. So if we go hits to at-bats, that would be 181 to 521. Okay, so 181 hits to 521 at-bats. So that would be my ratio. This is my ratio right here. All right, so now we often calculate it out. So, if you throw that into a calculator, you're going to get 0.347. So that would be his batting average right there. Okay, that's his batting average. That's kind of what you're looking at. But that stems from this ratio. Okay. So we have Central High School. We have 520 students that participate in activities, sports programs, and the total number is 1850. Find the athlete to student ratio. Okay, I'm going to change colors here for a second. So if it's athlete to student ratio, okay, so there's 520 athletes. And I know that there's 1,850 students, but from the 1,850 or 1,850, we have to subtract those athletes, okay? Because the athletes are already being counted over here. So my ratio would just be 520 athletes to 1,330, students. They might be involved in other activities, but they don't play a sport. That's kind of what my comparison is. Okay, so it'd be athlete to student there. Okay. So sometimes ratios compare two more numbers. This is called an extended ratio. So if A and B are two quantities, B and C are two quantities, A and C are the first and last quantities. Sometimes this extended ratio is written like so. A, B, and C. Sometimes it's written like that. So that if you might see it like this, you might see it like this. Those would all be considered an extended ratio. And this thing is just these three, put together into one ratio. Okay, so let's talk about what that might look like. So the ratio of the measures of the angles of a triangle is 3, 4, and 5. Find the measures of the angles. So the ratio of the angles is 3, 4, and 5. Find the measures of the angle. So 3, 4, 5. That's my extended ratio. Okay, so we're talking about the measures of an angle in a triangle. Well, so here's what kind of the representation is. So 3 times some number plus 4 times some number plus 5 times some number is going to equal 180. Okay, that's how the ratio works. Okay, 3 times 3, 4, and 5. If they're all multiplied by some number, then they're going to stay in that ratio, and we know that the sum total is going to be 180. So 3, 4, and 5 together is 12. A little division. So 180 divided by 12 is going to equal 15. Oh, okay, so we know that this is like the common number that's in common with all of them. So then when I go to do this, so 3 times x would be 45. 4 times x would be 60. And 5 times x is going to be 75. There's my angles right there. Okay, so that's what I do. That's what I do there. All right, so now we're going to sides. Okay, so now we're going to sides of a triangle. So we'd have 3x, 3x, 8x. So it's an isosceles triangle. But now they tell me that my perimeter is this. So 3x plus 3x plus 8x equals 392. Okay, so remember 3 times some ratio, 3 times some number, 3 times some number, 3 times some number, or 8 times some number. All that's got to add up to 392. So what does this become? This becomes 14x equals 392. So a little bit of algebra, and I get it to be 28. So now 3 times 28 is just going to be 84. And 8 times 28 is going to be something much, much larger. That's going to be 224. And that's my answer right there. That's my answer right there. That would be my relationship where it's 3, 3, and 8. Okay. So Jane jogs the same path every day in the winter to stay in shape for track. She runs at a constant rate. She spends a total of 39 minutes jogging. The ratio of the times of the 4 legs is 3, 5, 1, 4. How long does the second leg of the jog take? So that second leg would be the 5. So she spends, 3 plus 5 plus 1 plus 4 is going to be equal to 8, 9, 13. Okay, so that's going to be, so it's like she splits it up into 13 parts. So the first one would be like 3 out of 13, then 5 out of 13, then 1 out of 13, then 4 out of 13. Okay, it's just a different way to think about it. If the other way makes sense, then the other way makes sense. But it's like saying, if you broke it up into time, she spends most of her time in that second leg. Okay, that's what they're saying. So now, if you consider it to be 3x, 5x, 1x plus 4x equals 39. So 13x equals 39. So x is going to equal 3. So x equals 3. So how long does the second leg take her? Well, 5 times 3 would be 15. So she spends 15 minutes in that second leg to of her jog. That's what I'm doing right there. Okay. So now proportions are basically comparing two ratios. Okay, so you're two ratios that are equal to each other. So you have A over B equals C over D. And in solving, I don't like cross multiply. I think that I like saying cross products there a little bit. So if I have A over B and that equals C over D, I want to go A times D is going to be equal to B times C. That's kind of how I'm solving that, all right? So I'm going diagonally. A times D is going to be equal to B times C there. So now let's take a look and see what we got here. So some of this will need some algebra, which is fine. Okay, so here if I go diagonally, that's 8 times x equals 5 times 12. That's 8 times x equals 60. And then from there, it's relatively straightforward. 60 divided by 8 is going to be 7.5. I'm done. That one's pretty straightforward. This one has a few tricks. So this one would be 2 times x minus 2 equals 4 times x plus 4. So a little distribution here. So 2x minus 4 equals 4x plus 16. So if I subtract 2x to both sides, and I subtract 16 to both sides, that's 0, that's 0. That's going to equal that. Little division, that becomes 1. So x is going to equal negative 10. That would be my answer. Okay, so that one's a little tricky. You know, there's a negative involved, but still doable. 8 down here is 8's a challenge. I'll warn you right now, 8's a challenge. So if I take 2x plus 3 times x minus 1, that will equal 3 times 6. Okay, right side's easy, right side's 18. Left side, you need to do double distribution, or some people call it foiling, but it's the same idea. So you go 2x times x, which is 2x squared, 2x times a negative 1, which is minus 2x, 3 times x, which is 3x, 3 times negative 1, which is negative 3. So that's 2x squared plus x minus 3 equals 18. So now this is where factoring and those things have come into play. So what I need to do is I need to subtract 18 over. So it equals 0. So now I need to factor this thing. So what I need is what multiplies, 2 times negative 21. What multiplies to 42 or negative 42 but adds up to 1? Okay, so I start thinking about what are my choices for 42? So I arrive at 7 and negative 6. So I rewrite that plus, let's do this. So I'm going to go minus 6x plus 7x minus 21. Okay, I rewrote it using my factors. So then I go parentheses, 2x, x minus 3. And over here, 7, x minus 3. So I put together what's on the outside, I put together what's on the inside. So then I look and set each part equal to 0. So x equals 3. 2x equals negative 7, so x will equal negative 7 over 2, or negative 3.5. Okay, now I went a little fast there. This is a good review of factoring with something in front of x squared, something you've seen before, but something that's it's tricky for a lot of kids, so I wanted you to kind of see what I did. So I foiled it, okay, I multiplied this back together, brought 18 over, then I had to split it back apart, and then my last step is take each part, set it equal to 0, and solve it. Okay, so take a moment and revisit that. not sure what's going on. Okay, so let's take a look. So Katie surveyed 30 students in her class, found out that 18 have iPads. There are 870 students in Katie's school. Predict the total number of students with an iPad. So we want to compare iPads with students. Okay, iPads with students. So if 18 kids owned an iPad out of 30 students, we can make a general guess if there's 870 students that we expect to follow this same ratio. Okay, and again, I can simplify this. I can divide both top and bottom by 6, and I'd go 3/5. And that's going to follow that same pattern. So 5x equals 3 times 870. So 870 times 3 divided by 5, x is going to equal 522. So that's my answer. That's my answer. So I can expect approximately 522 students. That's what I'm looking at. Have an iPad, okay? Okay. So Shelley can read 20 pages in 30 minutes. How long will it take her to read 152 pages? So similar to before. So if you're going per pages per minute, now you're going to compare that to pages, and you're going to go total minutes. So it'll be 20 pages in 30 minutes, but then comparing it to how long is it going to take me to do 152 pages, how long is that going to take me? Well, that's just going to be 20x equals 30 times 152. So 20x is going to be 4560. So divide by 20, just a little algebra. And you should get 228 minutes. Okay, so you really want to know, divide that by 60. That's 3.8 hours. So it'll take 3.8 hours, so not quite 4 hours for her to read that book. Okay, that's kind of all I got. So now, once again, you're looking at 5.1, knocking out the quizzes, and making sure you get all of your questions answered. Okay.